कुबेर लक्ष्मी चिरंती क्षेत्र Yes, good morning, students. So today we'll discuss about hydrogen. Okay, so we are going to discuss the topic hydrogen. So hydrogen, it is the first element which is present in the periodic table, right? So this is the representation of hydrogen. So hydrogen represents like this, right? H1. So the number of proton and electron, okay, it is 1. So your hydrogen, what is hydrogen? It is the most abundant element which is found in the universe. Okay, so it is most abundant element found in the universe, and it is the third most abundant found in the surface of the globe. Okay, so this is about hydrogen. So hydrogen, it is the most abundant element. So it is found in most abundance. So hydrogen atom, okay, hydrogen, when you are talking about hydrogen atom, it is the smallest atom of any. Okay, so many elements are present. So out of so many elements, hydrogen is the very smallest element. So this hydrogen atom, it consists of what? It consists of one proton and one electron. So it consists of only one proton and it consists of one electron. So the proton is in the center, and so you can see here. So proton is in the center and the electron is revolving around the nucleus, right? So proton is, so it is in the center, and electron is revolving around the nucleus. Okay. Then when you are talking about hydrogen gas, when you're talking about hydrogen, so when you are talking about hydrogen atom, it consists of one proton and one electron. And when we are talking about hydrogen gas, so it consists of what? Two atoms of hydrogen. So when two atoms of hydrogen bond together, so they make a molecule of hydrogen, that is H2, right? H2 gas is nothing but your atoms, two atoms of hydrogen. So the first element, so this is what? It is a first element in the periodic table with atomic mass of 1, unified mass. U is nothing but unified mass, and atomic number 1. Okay, so this is about hydrogen. So who discovered this hydrogen? Okay, so in 1766, there was a scientist named Henry Cavendish. Okay, a scientist, name of the scientist was Henry Cavendish. He was the first to recognize hydrogen gas as a distinct substance. So remember, so who was the scientist who discovered hydrogen was Henry Cavendish. Okay, in year 1766. So what is the structure of hydrogen atom? So as we discussed, so hydrogen atom, it consists of proton in the center and nucleus, or the nucleus of the hydrogen atom and a electron. Okay, so proton is in the center, okay, or it is called as nucleus, and the electron is revolving around it, okay, around the proton. So this is hydrogen molecules, right? We discussed about hydrogen atom. So this is hydrogen molecule. So what is hydrogen molecule? When two atoms of hydrogen combine, right? When two atoms of hydrogen combine, they give you a molecule of hydrogen. Okay, H2. So here you can see, so there is one electron, right? So there is one electron here. In this hydrogen has one electron. So this hydrogen has one electron. So one electron from each hydrogen, it combines and it forms H2 molecule. You can see here the combination, right? So it is forming a covalent bond, right? So there is equal sharing, mutual sharing of electrons is taking place to form a hydrogen molecule. So what is the position of hydrogen in the periodic table? So you can see here. So this is your periodic table. Where is the hydrogen placed? So hydrogen is placed. So hydrogen is placed here, right? So hydrogen at the left top corner is your hydrogen. So this is the position of the hydrogen in your periodic table. Next. So resemblance with other elements. So how this so still the position of hydrogen, right? A position of hydrogen is under discussion. Why? Because it acts like a alkali metal as well as it acts like a halogens, right? So resemblance of hydrogen with other elements. So as hydrogen, it is placed at the top left corner, okay, at the top position in the left corner. So it resembles both as alkali metal as well as halogens, right? So halogens are what? They are the 17th group elements. So here why it resembles like alkali metal. So as hydrogen, how many electrons it has? It has only one electron. So hydrogen has electronic configuration of 1s1. As it has one electron, so it is similar to the electronic configuration of alkali metals. So as you know that in alkali metals, okay, as you know that in alkali metals, the outermost electronic configuration is ns1. So it resembles like hydrogen. So hydrogen, it also has 1s1 as electronic configuration of alkali metals. So these hydrogen, they form what? Oxides, halides, sulfides like alkali metals. And it gains an electron to become an anion. It has high ionization enthalpy and forms covalent bonds. Okay. Then, so because of these properties, it is acting as a alkali metals. Then why it is acting as halogens? Why it is acting as halogen? Because in terms of ionization enthalpy, hydrogen resembles halogens. Okay, like halogens, hydrogen forms diatomic molecule, right? So as halogens, they form diatomic molecules F2, I2, Cl2, Br2, right? So like this, hydrogen also forms diatomic molecules. It combines with the elements to form hydrides. Hydrides. So it forms hydrides, that is metal hydrides, right? When it combines with metal, it forms metal hydrides and a large number of covalent compounds. So, but it loses an electron to become a cation, and hydrogen reacts with the halogen themselves. So in halogens, so as you know, the outermost electronic configuration is ns2 and np5. So it requires one electron to complete its octet. So same with respect to hydrogen also, it requires one extra electron, that is 1s1 it has. So it wants one electron to become to complete its duplet state, right? So it resembles both as alkali metals also as halogens also. So then we'll start with the preparation of dihydrogen. So these are the preparation of dihydrogen. So there are number of methods for preparing dihydrogens from metal and metal hydrides. Okay. So the first is by preparation it with the preparation of hydrogen from zinc with dilute acids. Okay. So we'll see. So this is a laboratory preparation of dihydrogen. So how you are preparing your dihydrogen H2. So that is, it is usually prepared by reaction of granulated zinc with dilute HCl. So you can see the reaction zinc, okay, zinc granules are taken and you are reacting with dilute HCl, okay, H plus ions, and you get Zn plus 2 and H2 gas is liberated. So this gas, H2 gas can be prepared, that is dihydrogen gas, this can be prepared in laboratory. Then it can also be prepared by zinc with aqueous alkali, okay, alkali. So alkali, they have taken a strong alkali, that is NaOH. So your zinc plus NaOH gives you Na2ZnO2 plus H2. So by these two methods, you can prepare your dihydrogen at laboratory conditions. How is a laboratory condition means what? In the lab you can prepare. Then commercial production means what? Commercial production means when you want to produce your H2 gas, that is hydrogen gas, at a very large scale. Okay, in laboratory method you can prepare the hydrogen gas at very small quantity, and in the commercial production here you prepare your hydrogen at a very high quantity. Okay, amount of hydrogen prepared will be more here. So how you are going to prepare commercially? So the first is by electrolysis. Electrolysis is what? You are going to supply electric current. Okay, so you are going to supply electric current in acidified water. So water you are going to take in a container and you are going to add H plus ions. Why you are adding H plus ions? So that there should be some ionization. Okay, so there will be transfer of charges. So there will be some chemical reaction taking place. Okay, so electrolysis, after supplying the electric current in the acidified water using the platinum electrode, it gives hydrogen. So this is the reaction. Okay, 2H2O, electrolysis giving you H2 and O2. So this is electrolysis of acidic water. Then second is electrolysis of warm aqueous barium oxide solution between nickel electrodes. So same electrolysis you are going to do. You are going to pass the electricity in the warm aqueous barium oxide solution. Okay, you're going to take in a container barium oxide solution, and to between the nickel electrodes. So the electrodes taken are of nickel, and you're going to pass the electricity, and then the chemical reaction takes place at anode and cathode respectively. So this is the second method of preparation. Third is by manufacture of sodium hydroxide and chlorine by electrolysis of brine solution. Brine solution is nothing but your NaCl solution, okay, salt solution. So how you are going to prepare electrolysis? That is, you are going to pass your electric current in a container having brine solution. So when you are passing the electric current in the brine solution, so you know that there are Na plus and Cl minus ions. So there will be chemical reactions taking place at cathode and anode respectively, and thus it is into sodium hydroxide and chlorine. Okay, and there will be from this method also you can prepare your uh, hydrogen. Okay, then reaction of steam on hydrocarbons or coke. Hydrocarbons is nothing but your compounds of carbon and hydrogens. Okay, so when you're passing steam on hydrocarbons or coke, coke is also nothing but your carbon. Okay, at high temperature in the presence of catalyst, it gives you hydrogen. So what is the reaction? Remember this reaction, methane plus water. Okay, in the presence of catalyst taken is here nickel, and the temperature is 1270 Kelvin. Okay, the temperature here is 1270 Kelvin. So in the presence of nickel and 1270 Kelvin. Okay, so it gives you what? It gives you CO2 plus H2. So it gives you CO2 plus H2. Okay, and this is the reaction. So important reaction, remember. So CO plus H2 is nothing but it is called as syngas. Okay, it is called as syngas, or it is called as water gas. Okay, it is called as water gas. CO plus H2. Remember this. Then we'll see the properties of hydrogen. So what are the physical properties? It is colorless, odorless, and tasteless. Okay, it does not have color, it does not have smell, and it does not taste. So it is combustible, so it can easily heat up. Okay, it is combustible. Hydrogen and helium is present on the surface of the earth. Okay, so this is the physical properties. Next, we'll see the chemical properties. So the chemical behavior of hydrogen is like other molecule, which depends upon the bond dissociation and enthalpy. What is bond dissociation enthalpy? It is any energy required to break the bond. Okay, dihydrogen is what? It is the atoms. Okay, two atoms of hydrogen make up dihydrogen molecule. So to break up the energy, so the chemical behavior of this dihydrogen, it depends upon the energy associated, okay, to break the bond. Then second is the inertness of dihydrogen at room temperature is due to dissociation enthalpy. Since its orbital 1s is empty, it combines with almost all the elements. So as you know, there is only one electron, so it can combine with almost all the elements. So it can easily lose one electron to form H plus. So as it has one electron in the outermost shell, it can easily lose one electron, as well as it can gain electrons. So when it loses electron, it forms what? H plus ion. And when it loses, gains electron, it becomes H minus. Okay, or when it shares electron, so it forms what? Single bond. So when it is sharing, it forms the bond. So reactions of hydrogen with other substances. So we'll see. So when it so this is a chemical properties of hydrogen, you can say. So when when dihydrogen, so you can see the reaction when dihydrogen, okay, when reacts with halide, okay, it forms hydrogen halide. So here the halogen taken is AfClBr iodide. Okay, so when dihydrogen, it reacts with X2. X2 is what? Is your halogen. Okay, in the gaseous state. So this represents your gaseous state. Okay, G in the bracket represents your gaseous state. It forms 2HX. HX is what? Hydrogen halide. So it leads to the formation of hydrogen halide. Next, it reacts with dioxygen. Dioxygen is what? O2. Okay, when it reacts with O2, H2, when it reacts with O2, it forms what? Water. Okay, it is highly exothermic reaction. It is highly exothermic reaction. So remember this. This is the second chemical property. Okay, then the next is reaction with dinitrogen. Okay, so with nitrogen, what it forms, you can see here. With nitrogen, what it forms? It forms ammonia. Okay, so hydrogen, when it reacts with N2, it forms ammonia. With metals, when hydrogen reacts with metals, it forms what? Metal hydrides, right? It forms metal hydrides. So MH is nothing but your metal hydrides. Okay, M can be your any alkali metals. So for example, if I take Li, okay, lithium hydride, so it can form lithium hydride, okay, lithium hydride, sodium hydride. Okay, so these are some of the, so LiH, NaH. So these are the different hydrides which are formed by combining with metal. So when your dihydrogen reacts with metal, it forms metal hydride. Then with reaction with metal ions and metal oxides. Okay, so H2 when it reacts with a metal. So what is this? Palladium. Okay, so this is what? 2 plus Pd plus 2. So it forms Pd plus 2. So this is a Pd plus 2H plus. Okay, so it is reducing. So there is reduction. So there is reduction. So with reaction with metal ion, it acts as both oxidizing as well as reducing agents. So here this is a reducing a reduction. Okay, it is undergoing reduction, and here it is a oxide. So it is acting as a oxide. So H2 plus MO gives you metal plus water. Okay, so these are the reaction, chemical reactions occurred by H2. Next is organic compounds. So hydrogenation of vegetable oils. Okay, so where nickel is acting as a catalyst to give you edible fats. So when you are undergoing hydrogenation, means what? You are adding H2. So across, when you are having a organic compound which is unsaturated organic compound, and you add your you do a hydrogenation on that reaction, you get a edible fats. Okay, then hydroformylation of olefins yields aldehydes, with further gives you alcohols. Okay, next is uses of dihydrogens. We'll see uses of dihydrogen. So it is used in synthesis of ammonia. Okay, it is used in the manufacture of nitric acid. Then it is used in the production of vanaspati fat by hydrogenation of fat, vegetable oils. It is used in production of methanol. It is used in manufacture of metal hydrides. Okay, it is used in manufacture of metal hydrides. Then preparation of hydrogen chloride, used in the reduction of metal oxides into metal. Atomic hydrogen and oxyhydrogen used for cutting and welding. Then it is used as rocket fuel. It is used for generating electricity. So these are some of the uses of dihydrogen. Okay, so these just go through. So these are some of the examples, or these are the uses of dihydrogen. So next we'll discuss about water. So, so you know, living beings. So the most important source is water only, right? For living beings to survive. So the most important source is water, right? So humans have 65% of water, while some plants have 95% of water. So it is a main source for living beings to survive. Okay, so it is a solvent of great importance and necessary for survival of all organisms. So the distribution of water around the globe is not uniform. Okay. So the distribution of water around the globe is not uniform. So here you can see this is the this is a structure of water molecule. So there is a lone pair of electron. The angle is 104.5 degree. Okay, so this is the structure of water molecules with two lone pairs of electron. Okay, so this is structure of water. Then we'll see the chemical properties of water. So it is amphoteric in nature. What do you mean by amphoteric? It acts both as acid as well as base. Redox reaction, it undergoes redox reaction. What do you mean by redox reaction? It acts both as oxidizing agent as well as reducing agent. So water plays an important role in redox reaction. Then hydrolysis reaction and hydrate formation. So because of the aqueous solution, many salts they can be crystallized as hydrated salts. So there are different types of water molecule associated. So it forms whenever the water is there with the compound. So it forms coordinate water. Okay. Then interstitial water. What do you mean by interstitial water? Means the water molecule will take the interstitial sites and it forms hydrogen bonded water. Okay. If the water molecule will be associated with the hydrogen bonded. Okay. So these are the some of the salts. Okay, whenever there are aqueous solution, many salts, they will crystallize as these three types. Then what do you mean by hard water and soft water? So water which contains salts of magnesium and calcium in the form of hydrogen carbonate, chloride and sulfate is called as hard water. Okay. So water which contains salts of magnesium and calcium in the form of hydrogen carbonate, chloride and sulfate is called as hard water. So it does not give lather with soap. Okay. It does not give lather with soap. And this water free from soluble salts of calcium and magnesium is known as soft water, and it gives lather with soap easily. Hard water is of two types. So the hardness of water is of two types: temporary hardness, permanent hardness. So how you can remove the temporary hardness? So first is by boiling. Okay, by boiling you can whatever the soluble magnesium hydrogen carbonate is there, it is converted into insoluble magnesium hydroxide, and calcium hydrogen carbonate is converted into insoluble calcium carbonate. Okay, and the precipitate, you know, if it is one is soluble, one is insoluble, after filtration you can remove it. Okay, so the filtrate which is obtained, it will be a hard water. So these are the reactions. Okay, these are the reactions. Like this you get your you can remove the temporary hardness. Second is Clark's method, important here. That is the calculated amount of lime is added to hard water which precipitate outside calcium carbonate and magnesium hydroxide, which can be filtered off. So this is the reaction. Okay, so like this it can be filtered out. Okay, so a calculated amount of lime is added to hard water. Okay, so which precipitates out to giving you a calcium carbonate. So this is a reaction. So calcium hydrogen carbonate plus calcium hydroxide giving you, okay, when you so plus H2O giving you CaCO3. So this is the reaction. So how you remove the permanent hardness? Treatment with washing soda. Okay, if you washing soda reacts with soluble calcium and magnesium chlorides and sulfates to form insoluble carbonate. So this is the first method for permanent hardness to remove. Second is Calgon's method. Okay, so that it is a commercial. This is known as Calgon. So that is sodium hexametaphosphate. So sodium hexametaphosphate is nothing but it is called as Calgon. So it is added to hard water, so which forms a complex, so which can be removed easily. Okay, so it can, so by this you can separate your temporary hardness, you can remove it. Then ion exchange method. So when sodium aluminate silicate is added to hard water, exchange reaction takes place. So there will be exchange of ions. Okay, then synthetic resin method. So hard water is softened by synthetic cation exchangers. So this this method is more effective than the zeolite method. Okay, so synthetic resin method is more effective than the ion method. Next we'll see hydrogen peroxide. So it is a chemical used in pollution control, treatment of domestic and industrial effluents. So preparation, so from barium oxide, okay, from barium peroxide, when you react with H2SO4, okay, you get barium sulfate H2O2 plus 8 water molecules. So when you are reacting this, you get barium sulfate. So this is the first preparation of your peroxide. So hydrogen peroxide. Then peroxysulfate. Okay. So on hydrolysis yield hydrogen peroxide. So this is the another reaction. So physical properties. So H2O2 is very pale blue liquid with melting point of 272.4 Kelvin, boiling point of 423 Kelvin. So it is miscible in water, okay, in all proportions, and it forms hydrates H2O2.H2O. A 30% solution of H2O2 is marked as 100 volume hydrogen peroxide. So you can see this is a structure. Okay, this is like an open book. It is like an open book. So hydrogen peroxide, the structure is like an open book. Then what are the chemical properties? So hydrogen peroxide, it acts as reducing agent in both acidic and alkali media. Okay, so it acts both as oxidizing agent as well as reducing agent in both the conditions. So these are the reactions. Just go through the reactions. So these so here the hydrogen peroxide is acting both as oxidizing agent as well as the reducing agent in both the condition. Acidic condition where you are taking acid, okay, acidic medium, and alkaline like alkali solutions, okay, NaOH, KOH are taken. So these are the different chemical properties of hydrogen peroxide. So where it is used as hair bleach, okay, it is used as hair bleach and mild disinfectant used to manufacture chemicals like percarbonate. It is used in synthesis of certain food products. It is used in industries as bleaching agent, and it is used in environmental chemistries. Okay, so these are some of the uses of hydrogen peroxide. Then
Excuse me,
yes,
ma'am. Percarbonate, where it was used?
for
ಮ್ಯಾಮ್ ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಯೂಸ್ ಟು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಕೆಮಿಕಲ್ ಲೈಕ್ ಪರ್ಕಾರ್ಬೋನೇಟ್ ಅಂತ ಇದೆಯಲ್ಲ ಮ್ಯಾಮ್, ಅದ್ ಯಾವ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಯೂಸ್ ಆಗುತ್ತೆ? ಮ್ಯಾಮ್
used
ಇವಾಗ
to
ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್
manufacture
ಹೇಳಿದ್ರಲ್ವಾ,
chemicals
ಯೂಸ್
like
ಟು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಕೆಮಿಕಲ್ಸ್ ಲೈಕ್ ಪರ್ಕಾರ್ಬೋನೇಟ್ ಅಂತ,
yes,
ಅದು ಯಾವ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಯೂಸ್ ಆಗುತ್ತೆ ಅಂತ ಮ್ಯಾಮ್?
where percarbonate is used.
ಎಸ್ ಮ್ಯಾಮ್.
Percarbonate solutions are used as a chemicals only, for different in industrial purposes and all. Hydrogen peroxides, it can be used for manufacturing the chemicals like permanganate. So percarbonate is also chemical. So to prepare this percarbonate, okay, you are using hydrogen peroxide. So from hydrogen peroxide, you can manufacture the chemicals like percarbonate.
Thank you.
So D2O, okay, what is D2O? It is a heavy water. What is D2O? D2O is nothing but deuterium. Okay, so there are three isotopes of hydrogen. Okay, what are the three isotopes of hydrogen? Protium, deuterium, and tritium. Okay, so when you replace the protium by deuterium, D, okay, D is nothing your D2O. So this is used as a moderator. It is used as a moderator in nuclear reactors and in exchange reactions. So it is used as moderator, coolant. Okay, it is used as a coolant in nuclear reactors. So nuclear reactors, it takes place at a so when the nuclear reaction takes place, so heavy amount of energies or heat is released, right? So to cool the reaction so that there should be no any hazardous reaction taking place, so you are using this D2O. So D2O, it keeps the temperature, or it keeps the temperature of the nuclear reactor cool. Okay, so it is used as a moderator. It is acting as a coolant. So it is prepared by exhaustive electrolysis of water as byproduct in some fertilizer industry. So it is used as a for electrolysis also, it is used as well as in some of the fertilizers industries. Okay, so it is used for preparation of other deuterium compounds. So these are the reactions you can see. Deuterated also this deuterated water is used to study the rate of reactions. Okay, if you want to calculate or to see the rate of reactions, how it is undergoing, so you can because heavy water, H2, okay, H is very light compound. Okay, it is a very light element. So by using this deuterated, as it is heavy water, okay, so the rate of reaction undergoes very slowly. So by this you can study the rate of reaction. So dihydrogen gas, it acts as a very important as a fuel. Okay, it releases large quantities of heat on combustion. So it releases more energy than petrol, almost twice. The only pollutants are oxides of nitrogen, which can be reduced by injecting a small amount of water in the cylinder to a lower temperature. Okay, so this dihydrogen gas, it is acting as a fuel. So this is very important role it is playing. It is acting as a fuel because it releases large quantities of heat on combustion. Okay, so so this is the all the important points covered in hydrogen chapter. Okay, so based on this, we'll solve some of the questions. So which pair does not show hydrogen isotopes? So you know there are three isotopes of hydrogen: protium, deuterium, and tritium. So which pair does not show the hydrogen isotopes?
A, ma'am.
Yes. So the correct answer is A. So A is the correct answer. So orthohydrogen and parahydrogen, what do you mean by orthohydrogen and parahydrogen? So these are substituted hydrogen. Okay, orthohydrogen. Ortho means what? Ortho will be like this. Okay, so ortho will be this will be substituted at ortho position, and para means at the, okay, these positions are nothing but your para position. Okay, so this protium, deuterium, so these are all deuterium, tritium and protium. These are the isotopes. This is not the pair, okay, of isotopes. So this is the correct answer. A is the correct answer, that it is not the pair. Yes. Under what conditions of temperature and pressure the formation of atomic hydrogen from molecular hydrogen will be favored more? Under what condition of temperature and pressure formation of atomic hydrogen from molecular hydrogen will be favored more? Okay, the answer is A. High temperature and low pressure. Okay, high temperature and low pressure. So your formation of hydrogen from molecular hydrogen, it takes place as, how it takes place? H2. Okay, H2 giving you H plus plus H. Okay, like two atoms of hydrogen. So here the energy release, so it will be positive. Okay, so here, since this is an endothermic reaction, so it is a endothermic process, it is favored by high temperature. Okay, so it is taking place with increase in the number of particles, thus it is favored by low pressure. So this is the condition. So H2, so H2 giving you H plus H. So this is a endothermic process. Okay, endothermic process means it should undergo, it should have a very high temperature. The condition should be high temperature and low pressure. Next, heavy water is. What is heavy water?
Option C, ma'am.
D2O. Okay,
Option
it is
C,
D2O.
D2O.
Option C.
Heavy water is used in atomic reactor as. It is acting as
Moderator.
it is acting both as well, moderator as well as coolant. Okay, moderator, it is used to slow down the reaction also, because in atomic reactor, as I said, that what happens, large amount of energy will be released or heat will be released, so it will slow down the reaction or the speed of fast moving neutrons, and also it is acting as a coolant, okay, to cool the reaction. Okay, so it is acting both as moderator as well as the coolant. C. So when two ice cubes are pressed over each other, they unite to form one cube. Which of the following forces are responsible to hold them together? It is D. Okay, hydrogen bond formation. So water molecules in ice cubes are held by what? Hydrogen bonding. Okay. Only thing is that ice like cage like structures will be because of this ice like cage like structure. So you know ice like it will be like cubes. Okay. So the cage-like structure, it will ice because of low density. Okay, it will have that ice like this cube-like structures. So the correct answer is because of hydrogen bonding. So hydrogen bond formation. Okay, so which is the force which is responsible to hold them together is nothing but hydrogen bond formation. Deionized water is obtained by passing hard water through. Deionized water, it is D, both anion and cation exchanger. Okay, so both anion and cation exchanger, deionized water. Okay, deionized water is nothing but the water that has ions. Okay, so these can be removed. So you know, deionized water, they have ions. So in the tap water, they have ions like Na plus, right, Ca plus. Then in your pipes, pipes, it has Fe plus 2 and Cu plus 2. Okay, and some other ions are also present in the ionized, deionized water. So you want to ionize this, you want to remove the ions. Okay, so that time what you are going to use, you can use both the, so there are different, both types of ions can be present, anion and cation. So you have to pass the deionized water, that is the, to obtain the deionized water, you have to pass the hard water through anion and cation exchanger. Which of the following statements do not define the characteristic property of water? Okay, water is a universal solvent. Which characteristic does not define? Yes, which characteristic do not define? It has high range. It has okay, it can dissolve maximum number of compounds, none of the above. Okay, so the correct characteristic is what? So you know that the dielectric constant, okay, dielectric constant is high. The dielectric constant is high. Okay, so the characteristic which do not define the property of water is second one, B. Why? Because the dielectric constant of water is high. So water has high dielectric constant, that the dielectric constant value is 82. Okay, so it has a liquid range also, it has liquid range, and it can dissolve maximum number of compounds also. Okay, so because of this, it is called as universal solvent. So the correct answer is B. It has to be high dielectric constant, not low. So this is, it is not defining it. The boiling point of water is high because boiling point of water is high because
Ma'am, option D.
yes,
Option C, ma'am.
water molecule is associated due to hydrogen bonding. Okay, so you know that in the, if you take water molecule, so if there are water molecule present, so in the so if you take water molecule, so they will form what? It will form intermolecular hydrogen bonding. What do you mean by? So you know hydrogen bonding. Okay, hydrogen bonding. There are of two types: intermolecular hydrogen bonding and intra. Right? What do you mean by inter? Inter means between different atoms. Okay, different atom or different molecules. Okay, so the hydrogen bonding is found between different molecules, and intra means it is within the same molecule. Hydrogen bonding is formed. Okay, so this is the boiling point of water is high because of water molecules are associated due to hydrogen bonding. Hydrogen peroxide is obtained by the electrolysis of. Yes, hydrogen peroxide is obtained by the electrolysis of.
Option B, ma'am. Option C, ma'am.
Option B, ma'am.
The correct answer is sulfuric acid. Okay. So the electrolysis of 50% H2SO4 at the temperature is 0 degree. They are using the platinum electrodes. Okay, you are using the platinum electrodes, which leads to the formation of poor sulfuric acid. Okay, poor sulfuric acid at anode. So when you take sulfuric acid, okay, you are going to take 50% of sulfuric acid at 0 degree Celsius. The electrode use are platinum electrodes. So it leads to the formation of poor disulfuric acid, that is H2S2O8. So this is formed at anode. At anode, this is formed, and at cathode, H2O2. Okay. So this, wait. So what you're going to do, you're going to take 50% sulfuric acid at 0 degree Celsius. The electrodes used are platinum electrodes. So at anode, what is formed is poor disulfuric acid, okay, H2S2O8, which is formed at anode. So this will further undergoes hydrolysis. Okay, it will undergo hydrolysis to form what? H2O2. Okay, this will undergo hydrolysis to form H2O2. So the correct answer is B. The HO bond angle in H2O2 is. So, see here, HO bond angle in gas. Okay, it is given as 94.8. And HOO bond angle in solid is 101.9. Okay, so the nearest value. Okay, so in solid crystal, it is given as what? It is 101.9. So when you take a average of this, okay, nearest value will be what? It will be 95 degree. Okay, 95 degree plus or minus error will be there of 2 degrees. So it is what? 97. So B. Okay, remember it is B. So you are going to take the average of this two. It is 95 plus or minus 2 degrees. So it will be 97. So the bond angle in H2O2, they have not asked specifically for gas or in solid crystal. So you are going to take the average of both. Hydrogen peroxide is, yes, we have discussed, we have seen the chemical properties of hydrogen peroxide. It acts both as oxidizing agent as well as the reducing agent. So following are the reactions. So you can see how it is acting as both oxidizing agent as well as reducing agent. Okay, so these are the following are the reactions. When sodium peroxide is treated with dilute sulfuric acid, we get. So the reaction is like this. So we are going to treat sodium peroxide Na2O2 plus you are going to treat it with H2SO4. Okay. What is the reaction? You are getting 2 Na2SO4 plus 2 H2O O2. Just see if it is balanced. 2H2, okay, plus O2. Just see if it is balanced. 2 moles, oxygens are 4. Okay, 4, 8, 9, 10. Yes. Okay, so the correct answer is C. Okay, the correct answer is C. Sodium sulfate, hydrogen and oxygen. So when you are treating sodium peroxide is treated with dilute sulfuric acid, you get this. Okay, sodium sulfate, H2 and O2. The dihedral angle in gaseous H2O2 is. Yes, the dihedral angle. What is dihedral angle? It is the angle between the planes. Okay, dihedral angle is nothing but the angle between the planes. So the answer is C, 111.5 degree. Okay, 111.5 degree. H2O2 is stored in black bottles because H2O2 hydrogen peroxide is stored in black bottles because it undergoes auto-oxidation on prolonged standing. Okay, so H2O2, it decomposes into water and oxygen in the presence of light. So if it is directly, it is kept open. Okay, if it is kept in a, it is kept open to light, what will happen? It will undergo auto-oxidation. Okay, it will be converted into hydrogen and oxygen. So the correct answer is C. The decomposition of H2O2 can be checked by the addition of so to not so that it is so the this okay H2O2, if we want to prevent it, okay, if you want to prevent H2O2 from decomposition, then you have to add acetanilide. Okay, you have to add acetanilide. It is C. Okay, it is acetanilide. So if you want to prevent the decomposition of H2O2, then you have to add acetanilide. Bleaching action of H2O2 is due to its
Option A, ma'am.
yes, it is due to its oxidizing nature. Okay, so H2O2 giving you H2O plus oxygen. So here the nascent oxygen, okay, it is used or it is what it oxidizes the coloring matter. So whatever the coloring color, okay, when you want to do the bleaching, so whatever the color is there, so it can be removed or it is due to this nascent oxygen, it can be solved. Okay, so it is the bleaching action of H2O2 is due to its oxidizing agent because of the presence of this nascent oxygen. What would happen when a small quantity of H2O2 is added to a solution of FeSO4? So an electron is lost by Fe plus 2. Okay, how is the reaction? Just see Fe plus 2 plus H2O2. So what would happen when a small quantity of H2O2 is added to Fe plus 2? Okay, plus 2H plus, giving you what? 2Fe plus 3 plus 2H2O. So what is happening from plus 2? It is there is plus 3, right? So it is Fe plus 2 giving you Fe plus 3 plus 1 electron is lost. So an electron is added to Fe plus 2. So here what is happening? An electron is an electron is lost by Fe plus 2. Okay, the electron is lost. D is the correct answer. Okay, not C. D is the correct answer. Fe plus 2. See, what is happening? An electron is lost by Fe plus 2, right? From Fe plus 2, it is undergoing Fe plus 3. So there is increase in this. Oxidation is what? Loss of electrons. So it is undergoing oxidation. Hydrogen acts as an oxidizing agent in the reaction with
Option
C. Okay, that is calcium. How? Ca plus H2 gives you CaH2, right? So this is 0. It is undergoing plus 2 state. What is happening? Increase in oxidation number, right? Increase in oxidation number is oxidation, right? So Ca, which is 0 oxidation state, it is undergoing plus 2 state. So it is increase in oxidation state. So Ca is oxidized to Ca plus 2. In which of the following compounds does hydrogen have an oxidation state of -1. CH4, what is the oxidation state of hydrogen? Each hydrogen has +1, right? In NH3, it is +1. Okay, each hydrogen has +1. HCl +1 -1. Then Ca +2H2. So this is +2. Here it is. Each hydrogen is -1. So answer is D. D is the answer. So hydrogen, in which of this following compounds have oxidation state -1? It is D. Hydrogen does not combine with. So it does not combine with what? It does not combine with helium. Okay, it does not combine with helium. With rest of the metals, it will combine. Only with helium, it will not combine. A hydride of nitrogen, which is acidic, is, okay, it is N3H. It is N3H. So hydride of nitrogen, which is acidic, is N3H. This N3H is nothing but it is hydrazoic acid. Okay, it is hydrazoic acid, and this is acidic in nature. So this is acidic anhydride. This is acidic anhydride of nitrogen. So this is most acidic. Okay. The pH of D2O and H2O at 298 Kelvin is. So the pH is A. Okay, the answer is A. So pH of D2O is 7.35 and of water is 7. Okay. So pH of D2O is slightly greater than this. It is 7. Okay. Slightly it is greater than the water. Boiling water of heavy water is. Boiling point of heavy water is.
Option C, ma'am.
Yes, it is 101.4 degrees Celsius. Okay, boiling point of heavy water is 101.4 degrees Celsius. NH3 and H2O form NH4OH by. Okay, I'll write down the reaction, just see. So NH3 plus water. Okay, it forms NH4. How it forms NH4? By NH4 plus OH minus. So plus and minus, what it indicates? What type of NH4OH? Plus and minus is nothing but ionic bond. Ionic bond is also called as electrovalent bond. So answer is A, right? NH3 plus water gives you NH4 plus and OH minus. Okay, this is NH4OH. So this plus and minus is what? These are ions, right? So the ion, so there is sharing and so there is one is giving electron, another is accepting the electron, right? So it is A, electrovalent. Ionic bond is also called as electrovalent bond. Hardness of water is due to which pairs of the ions?
Option C, ma'am.
Yes, it is Ca plus 2 and Mg plus 2. Correct. So answer is C. H2O2 is used as. It is used as antiseptic, it is used as bleaching agent, it is used as propellant. Okay, the correct answer is all. So 4. Okay, it is used as all. It is used as antiseptic also, it is used as bleaching agent, it is used as propellant. So the correct answer is D. Which one of the following statements, if any, regarding hydrogen peroxide is false? Okay, just see, go through the points. So which one of the following statements regarding hydrogen peroxide is false? So this is correct. It is strong oxidizing as well as base reducing agent in both acidic condition. So it is decomposed by MnO2. Correct. It
Option C,
behaves as
ma'am.
a reducing agent. So it is C. Okay. It is more stable in basic medium. It is more stable in acidic medium. Okay. So this is the correct answer. Yes. So by this, we have completed the chapter hydrogen. Okay, please go through the concept and try to solve as many as questions possible. So, okay, we'll meet in the next class. Thank you. Thank you, students.
Thank you, ma'am.